All right, everybody, we've got a solar uptick in progress. We've got radio bursts. We've got new likely spots for major solar flares, a possible coronal mass ejection striking right now, and insane weather coming to the Gulf Coast. We'll tell you all about it and lots more here at the Smash News Network, least busted name in news, just the world's most comprehensive daily space weather and detailed solar imagery you'll find in the known universe. Let's take a look at those radio bursts. They came from this active region right here. Radio bursts are when a bunch of plasma kind of stands up in the solar corona that emits high amounts of radio frequency. This one was 245 megahertz radio burst, I believe. And we'll talk about coronal mass ejections a little bit later. There have been some. There was at least one decent one. Here's a little closer view of this radio burst producing region. That's some sweet imagery for you, right? We also do have massive plasma filaments, so that's another major story here. We've got really a historically high number of filaments at the moment, just about the most we've ever seen in the 6+ years we've been doing the daily space weather videos. You can see a huge one there hanging out at the South Polar region. Also a huge one there just east of the Earth scale. Filaments, filaments, filaments. And these two new sunspot groups over here on the east. The one south of the Earth scale there is currently the most likely place to see a large solar flare. Next, we'll take a look at sunspots here just for a brief moment. There is yesterday plus today, the browse data feature. And this sunspot here is capable of producing large flares as well. It does have the sort of magnetic fields that you would need to see there. And here are those magnetic fields in colorized magnetogram. Again, that is yesterday, August 28th, plus today to date. So the 28th and the 29th so far. Next, we'll take a look at volcanoes, and there's a fantastic image of Mount Mayon there, effusing a bunch of lava as it cascades down the slopes of the Philippine volcano. Let's see what else is erupting. Of course, Mayon. Effusive activity there, producing phoenix clouds, pyroclastic density currents. Semaru, producing a 14,000-foot plume of volcanic ash, and Makushin in the Aleutians, producing an unknown-size volcanic ash cloud. Popocatépetl, an uptick there in central Mexico. Popocatépetl now producing a 25,000-foot ash plume. Flight level 250. Flight level 190 over Sangay in Ecuador. Flight level 150 over Revenador in that same country. And Sabancaya exploding, producing a 22,000-foot ash plume in Peru. Flight level 220. Seismic activity very high as we saw a 7 magnitude quake in the East Java Sea. Here's the location of that. I should say the Java Sea, not the East Java Sea. There it is, just north of the Isle of Mataram. Now that quake was not accompanied by any email alerts from us. It was at extreme depth. So that quake was at over 500 kilometers estimated depth. If that would have happened at the surface, that would have been like an 8 magnitude quake. Fortunately, it didn't happen at the surface. So we'll call out the rest of the quakes here of 5 or greater magnitude. There have been some on the west coast of the U.S., by the way, just a side note there. And interestingly enough, there was a 5.4 just about 2 hours before that 7.1, although that was far to the northeast of the location of that 7.1. And then out of nowhere, a 7.1 magnitude quake strikes at 513 kilometers at 1955 Universal Time yesterday evening. And of course, you'll see many, many aftershocks there, like this 5.6 and this 5.4. Chile had a 5.1. That was at 23:24 Universal Time. And then there's actually a 5.9 there east of that 7.1 magnitude quake. So major seismic unrest happening there around Indonesia. That 5.9 was at 213 kilometers and at 4:34 Universal Time this morning. So continued seismic activity there, and time to get back to space. Next order of business is the 171 angstroms wavelength from SDO. This is a 24-hour video. And again, please note those areas on the eastern limb. Again, the most likely place to see a large solar flare at the moment would be that southeastern sunspot that just rose. It is quite magnetically complex. Let's take a look at the northeastern one first. Here's a fantastic view of that. And then this one will be the place to watch throughout the day. And here we've zoomed out for the full disk view, another 24-hour video from the Solar Dynamics Observatory. 171 angstroms depicts ionized iron. It shows the lower corona, the quiet corona. And let's talk solar stats. The next thing we'll cover is the 10.7 centimeter radial flux, which is at 142 solar flux units. Kind of surprisingly low, only 1 year or so out from solar maximum. There is the 1 year chart to put it in context for you. The black line is the 10.7 centimeter radial flux, a proportional set of data to the sunspot number. So let's see, we should see a small uptick here in the sunspot number today. We'll have two new groups. Sunspot number should rise by at least 12. It'll probably be more like 40. We should see something like about 40 sunspots added to this red line here today. Sunspot number should come back up to around 110 in the next 24 hours with those two new groups. They've got a lot of ombre, especially the southeastern one. So expect an uptick coming in both the radial flux and the sunspot number. Radial flux currently at 142 solar flux units. And NOAA not forecasting any sort of geomagnetic storms or geomagnetic unrest, but we might be about to go into geomagnetic unrest or storm conditions here, as we saw a rapid shift in the magnetic fields and also the plasma temperature and so on. Well, we'll get to it here in a moment. First Earth magnetic moment from space for the past 4 hours, and we are expecting to see a little uptick in this imagery. Again, because we just had a shift in the magnetic fields associated with the solar wind, as well as the plasma temperature, speed, and density. So you should see a little uptick happen here right at the end of this. Mainly just on the magnetotail side. Okay. Next, ground magnetic perturbations for the past 4 hours. Earth magnetic moment from the ground. We showed it from space. Here it is from the ground level. And at the moment, it is geomagnetically calm, but if we see this continued strong negative BZ signal, it could spark some significant aurorae. So KP index currently only at 0.67. This could rise all the way up into the high 3s or even into the 4s at the next update here. So here's what we're talking about, this rapid shift right here. Looks like a CME impact. So we saw the magnetic field switch from 8 nanotesla with a positive BZ, a BZ of positive 6, all the way to a BT of 7 nanotesla with a BZ of negative 7. At the same time, we saw an uptick in the solar wind density, and an uptick in the solar wind speed, as well as a change in the plasma temperature. So that looks like a CME impact. And if that continues on, well, it looks like it's weakening a little bit here as far as the magnetic fields. But that could spark some minor geomagnetic unrest here. It's something to keep an eye on. Now, when I say eye on, well, pardon the pun. One of the ways you can track the earthly effects of coronal mass ejection impacts would be viewing the geoelectric field. So this shows induction into the field. It's actually showing millivolts per kilometer here. So when we do see significant solar storm events, we often see major power grid induction. So these things happen almost instantaneously, and this is a great way to get an idea of the intensity of those events as you're actually looking at the empirical data there, the actual measurement. No major spikes here yet. So things remain geomagnetically calm, but that could change rather abruptly with those shifts in the solar wind. GOES magnetometers here showing some pretty high highs and high lows, at least in the past, with respect to the past 48 hours. However, if you look at the 7-day chart, it's not really that big of a deal. And let's move on to look at the top view ecliptic plane field plot. And as forecast, you can see the North Pole current sheet here is sort of extending out to the east a little bit farther. And that is exactly what you would expect with that strong sunspot in the southern hemisphere. So the sunspots, they constrain the magnetic fields. Essentially, they essentially constrain the magnetic fields. So if you have a strong sunspot in the south, you'll have a tendency to see a North Pole current sheet. And that's exactly what you're seeing happen here. You see right at the end, just in the past day or two, this depicts 4 days, you see this sector boundary crossing sort of extending out farther to the east. So no surprise there. If you understand how to interpret this data, it's what you would expect. So sector boundary crossing here has been delayed. Earth remains kind of right in the middle of a North Pole current sheet, depicted there in green. Here's our line of sight field plot. The photosphere magnetism there is depicted by the grayscale gong magnetogram. And then you've got the B field depicted in blue, north and south polar fields depicted in green for north and red for south. Next, coronal holes. And we are seeing an uptick here in coronal holes. Another thing that's been forecasted. Now, this is just basically a statistical forecast because this solar cycle has featured rather weak coronal hole activity. So that's a thing that can only continue so long because as the solar cycles progress, the north polar field migrates to the south and the south polar field migrates to the north. As that happens, coronal holes become transequatorial, which makes them a lot more what we call geo-effective, more likely to produce space weather events here on planet Earth. Next, we'll take a look at coronal holes from SDO's perspective. First, let's bring up the last image. We've got all North Pole coronal holes except the one setting in the northwest. So here's SDO 211 angstroms, which is our favorite wavelength through which to view coronal holes. And basically the diagram is like this. These are south, and all the rest of these are north. That is another 24-hour video. And let's move on to sunspots, and then solar flares and energetic particles. So first, sunspots. And by the way, don't forget to press the like button. Yeah, press the like button. The Smash News Network, least busted name in news, needs you to press share, like, comment, etc. Thanks to all of our longtime viewers and our new viewers. Congratulations, I realize the channel exists. We won't be celebrating 4,000 subscribers. However, 5,000 subscribers we will celebrate. So if you're new to the channel, press subscribe. And regardless, press like. So here's the sunspot situation. And again, we'll have a significant increase in the likelihood of large solar flares here and an uptick in the sunspot number. Okay, it looks like 3417 was already counted. So we will have an uptick in the sunspot number based on this new sunspot. That'll be known as 3418. So that's the situation. And here's the equatorial view from SDO Continuum. So that's what's going on with sunspots. Next, let's move to solar energetic particles and solar flare. So as far as SEPs, we ain't got none. But the likelihood of those occurring does go up with the likelihood of solar flares going up. Proton flux remains flatlined. And we have seen some upticks here in the X-ray flux. Let's take a look at where those solar flares might have been coming from. The largest event was actually right around midnight. Only a C2.34 class solar flare, a C2.34. So here is SDO 94 angstroms. And I think those flares might have come from this new group up here in the northeast. Certainly looks like it. So significant chance of solar flares, especially on the eastern limb. We've also got 131 angstroms. The other wavelength that takes 10 images per minute instead of only 2. In other words, it's got a 5 times higher temporal resolution. These wavelengths specifically formulated to view solar flares. It's also ionized iron, by the way, if you're wondering, a very thin band of the extreme ultraviolet light spectrum. Not visible to the naked eye, not visible from the ground level, only visible from space. That's why we use the SDO. And if you know, you know. Next, we'll take a look at what's going on overhead. If you're up before dawn and you've got clear skies, you might get a great view of the third brightest object over there. Earth's sister planet, Venus, as Saturn sets and Jupiter is high on the ecliptic. You've also got a view of the brightest intrinsic object visible from Earth, the star Deneb. See our previous videos for information about that. Also check smashamash.com/forum. We've got a cosmology forum that talks in great detail about the only known cosmic ray point source. Next, a solar system forecast. This is where things are today. Let's advance this 1 week. Here's where things will be in 7 days, on September 5th. And next, the astronomy picture of the day. A fantastic James Webb Space Telescope image here of an asymmetric galaxy, believed to have been perturbed by gravitational distortions with neighboring galaxies. Here you can see this very bright region down here, almost like another satellite galaxy forming there. Very bright region. There's the full view. Fantastic imagery there of, that is M65 from the Messier catalog, also known as NGC 3628 from the New General catalog. And it is interacting with its neighbor galaxy, M66. Perhaps similar to the future of what the Milky Way will look like. in a few billion years as it collides with the Andromeda Galaxy. M65, folks. The astronomy picture of the day at apod.nasa.gov. Next, CMEs. These are yesterday's coronagraphs. And at the end of the day, you will see a CME popping off here. Here's the aftermath of that. 33 more frames from today, August 29th. And let's take a look at that from some more views here. Here's a brief look at Soho Lasco C2 and C3. And let's blow those up a little bit. Let's blow them up and slow them down. So there it is at 2336 on the C2 and just after midnight there. Zero dark 54 on the C3. And we do not anticipate that to be an earthly directed coronal mass ejection. That looks like it is sort of behind the northeastern limb. There are some other outflows here happening around the same time. I think those are just separate events. So we'll just bring this back and play that through. And we'll show some greater detail as well here in just a minute. The C2 is a little bit behind the C3 here. We'll also look at stereo A before we show our custom coronagraph images. This diagram shows the locations of things like the Parker Solar Probe. Stereo A depicted by that red circle. It also shows Bepi Colombo, the solar orbiter, and so on. Here is stereo A along with its difference imagery. So pay attention to the time and date stamps there. This is, okay, there we go. Now we're on yesterday, and they're pretty well synced. Difference imagery on the right, raw coronagraph on the left. And here come our custom coronagraphs. So you can see that plasma there emanating from the northeastern limb. Not likely to have an earthly directed component. Here's a little closer view. You see that activity there from that new sunspot. 3418, did I say? That is the SDO 193 angstroms wavelength in the middle there. And let's subtract the coronagraphs and show just 193 angstroms. And next, we'll talk filaments. Filaments are a major story at this point because, well, just look at them. Look at all those dark absorption features. And we're back to the El Teide, Spain ground-based hydrogen alpha telescope. Let me shrink that down one more size. There we go. So there's El Teide, Spain, and look at the massive number and size and density of all these plasma filaments. There is a lot of coronal material pointed directly at the Earth at the moment. Those are bumpy features. And the likelihood of coronal mass ejections is 99.9%, as close to 100% as you could possibly get. So don't expect a lull in coronal mass ejection activity here. Expect coronal mass ejections to start occurring. We have some instability in some of these filaments, as you can see on this one. And we'll show the grayscale as well to show prominences. Huge filament down here at the southern hemisphere, right at the south polar region. Let's do a quick count. 1, 2. I think that's a single filament, so we'll say 3, 4, 5, 6, 7, 8, 9, 10. About a dozen large plasma filaments on the Earth-facing portion of the solar disk. That's a lot. All right. By the way, if you want to name filaments after living people, join us over on Twitter if you can stomach the pathetic fanboy sycophants constantly posting stuff about certain tech giants. And oh my gosh, it's very hard to watch. And think about how pathetic it's going to be on social media for the next year, folks. Yeah, as we approach the 2024 U.S. presidential election, you're not going to see the stuff you want to see. You're going to see a bunch of garbage on your feed. So yeah, come over to Twitter and post some stuff that has to do with space weather, Earth weather, etc. Maybe, I don't know, cycling, anything besides fanboy worship and politics, please. Hit us up. Follow the hashtag #NameThatFilament and name solar filaments after your friends and foes. You can even name them after yourself. Here are the past couple of hours from the GOES 16 SUVi. Looking at ionized helium here. And part of the reason why we stream this all day long on the Twitch channel is because it's so good at showing prominences and coronal mass ejections as they occur. So the GOES 16 has a much wider field of view but lower resolution than the SDO. So if you look at the SDO, it will show a lot more detail. However, it's not as good at showing coronal mass ejections because it has a narrower field of view. So you got to give up something to get something else, folks. That's the past 24 hours from SDO. And here are the past about 2.5 hours from the GOES 16. Same wavelength, both ionized helium in 304 angstroms. That brings us to bonus features, starting out with satellite charging hazards, and we don't have any. It is smooth sailing for satellites here. No high energy or low energy electrons building up in or on satellites. The GOES electron flux here has dipped a bit. It's just sort of in a low to moderate range, it looks like. There's the 1-year graph of the electron flux. And here is the forecast model. It looks like NOAA is expecting a little downtick in the relativistic electrons depicted by those green boxes, which are the forecast. We'll show the layer of the atmosphere where that's measured, way up there in the bridge between Earth and space, the F layer of the ionosphere. Here it is in vibrational frequency. So we are seeing some anomalies here in the ionosphere. Perhaps not expected anomalies. They might not have been expected, but we have not neglected to show them. So that's the raw vibrational frequency right there. Megahertz, millions of vibrations per second. And here is the anomaly gram. That's anomaly in megahertz from the 30-day median. So some scintillations happening there around the North Polar region. Quite a bit of red up there. Those are the low frequency type anomalies. And you can expect more ionosphere anomalies as we approach the September equinox. So that is what's going on. That data courtesy of Australian Government Bureau Meteorology. Here's the latest image. That's 10:15 Universal Time for the ionogram and 10:15 Universal Time for the anomalygram. Next, total electron content. It'll show you GPS errors, their most likely locations. Here's a total electron content forecast on a planet scale. This is literally a count of electrons from about 12,500 miles of altitude, the location of your GPS satellite. It's orbiting around the inner portion of the outer Van Allen belt. So from 12,500 miles down to surface level, those are the free electrons. And we'll also show the North Atlantic total electron content anomaly from the 10-day average. And some high electron content anomalies there around the Gulf Coast, interestingly. However, they are minor. So right in here, in the afternoon universal time, around 1330. And let's close out the space weather section with the latest intensitygram and the latest magnetogram. So this has been the most active region. I suspect there might be some more umbrae behind the limb there yet. So we only see one umbra. I suspect that is a beta gamma delta class sunspot. Expect additional umbrae to rise there based on the activity that we're seeing. And next we'll look at this one. This is perhaps the second most likely place to see a large flare. I think it might even be more likely from that northeastern group. But there's that southeastern group. And it is beta gamma class. I want to say that's beta gamma class. I suspect this group in the northeast, I think this group up here is probably beta gamma delta class. So there's a forecast for you, just based on the activity that we see. Beta gamma delta class sunspots are the most likely ones to produce large flares. This group here is magnetically complex as well. That is beta gamma delta class. This group down here, not sure on that one. That one is beta gamma class. Anyway, here's the full disk rockback. Whoops. Not yet. Don't jump the gun. Meteorology, it's coming. Because we discovered about 20 years ago that it's too easy to forecast the weather. So we bring it to you as a value-added service. We put it at the end of the space weather videos because they're the most timely portion, and we've got to get this video onto your screen. So we used to stream them live, but there were features lacking on certain video hosting platforms, so we have to record the videos instead to allow those features to exist on the channel. Anyway, we're looking at sea surface temperature here in the color gradation, and the animation there is wind speeds. And winds have actually picked up in this hurricane just in the past half an hour or so. I would also note that the water temperatures there, the sea surface temperatures in the Gulf of Mexico are nearly 90 degrees, 88.5 degrees where we have this green circle here. So there is a lot of potential energy there in convection. So this is a perfect way to strengthen this storm, which is exactly what's going to happen in the next about 24 hours. It's going to move pretty quickly and crash right into the Florida Panhandle. So this hurricane out here is actually going to make a sudden turn to the east, exactly as we forecasted days ago, based on the jet stream forecast. So that's sea surface temperature anomaly and surface winds, and we're going to get back to that here in a moment and show you more forecasts for the Gulf Coast. But first we'll do our standard showing the Earth's air masses. So as we bring space weather all the way down to Earth level, we like to show you the source of space weather, the sun, and then slowly zoom in to the planet scale. So here are the surface winds of the eastern world. This typhoon just loitering here northeast of Philippines. A very oddly shaped low pressure system out here east of Japan, out in the north central Pacific there. And another low here, kind of out in the middle of nowhere. So that's the surface wind scenario. Here is the jet stream scenario. Here are the jet streams of the central world. Shout out to our viewers from all around the planet. Who knew we'd make so many friends and foes by putting out daily space weather videos and meteorology content? Thanks to everybody who's tuned in. Don't forget to press the like button, or your soul shall be cast into an ever-deepening and darkening abyss of doo-doo diarrhea and cat pee. Here are the jet streams of the Western world. And these are the surface winds. So let's take another look at this. Now we're looking at wind. And we're going to move this ahead until tomorrow. So that system has moved more slowly than expected. And the winds are going to break down, but the low is going to actually reform here after it goes back off the coast. So around Charleston, it's going to be quite stormy there. Charleston, South Carolina. That's a GFS forecast for wind. Here's the Euro forecast for wind, and it's pretty similar there. So those are likely to be fairly accurate. The Euro forecast showing that low a little bit farther south, right on the Florida-Georgia border. Again, there's the GFS forecast for tomorrow at 1300. And there is the Euro forecast. Next, we'll take a look at it from the satellite's perspective. This is clouds and fog, shortwave radiation over the Americas. So intensification is going to happen there in the Gulf. There is a lot of hot water and a lot of potential for convection, which is exactly what's going to happen. We've got more forecasts for you. First, the smoke forecast, as we've got some air quality alerts in the north-central U.S., places like Minnesota and North Dakota. Going to see some pretty thick smoke rolling around there. Also the Pacific Northwest, some extreme smoke. That's firesmoke.ca. If you want to monitor that yourself, some major smokage in the north and northwest. Next, your weather.gov map. If your location is lit up on the map, click your location. There are too many locations to cover here. We don't want to get too local with the weather because these videos appear on YouTube, a worldwide platform with 10 billion monthly viewers. Weather.gov for your locations. Weather alerts. And here is the pressure and precipitation forecast. So first of all, check it out. The pressure it's only expected to drop down to about 1,000 there. That's the GFS 72-hour pressure and precipitation forecast. Yowzers. So it's going to retain a lot of its winds there after it makes landfall. Right on the Florida Panhandle, folks. Next, your 10-meter wind forecast. And you can indeed see that it is going to weaken just a little bit right before it makes landfall, according to that model. But there will still be quite high winds there. And you can see that other hurricane making an abrupt turn to the east as forecast. Next, total accumulated precipitation in inches based on the GFS model. And you're looking at 2 feet of rain there on that portion of the Florida Panhandle. That is suboptimal. Be ready for that one if you're in that area, because that will not be particularly pleasant. I mean, 2 feet of rain and also a foot of rain extending into Georgia, it looks like. 72-hour GFS total accumulated precipitation forecast looking bleak in some of those areas. Last but not least, the jet stream forecast. You can see the jet stream blasting that system off into the central Atlantic there. And not really helping with Hurricane Idalia which is just going to kind of slowly move up there and move back into the ocean and possibly re-intensify a little bit, as there is warm water off the coast of North Carolina as well. Next, your lightning mapper. We have had quite a lot of lightning in the U.S. in the past about 10 hours. I won't call out those specific zones. There it is. And let's check terrestrial strikes. At the moment, dag. Quite a bit of lightning around. In various locations. By the way, if you enjoy the content, try visiting our website. There is additional content there. Visit us on social media. You can find all the links at smashomash.com. We built this massive web ring for people like you. It was launched in February of 2019. Did you know we're still on Patreon as well? Yeah, we are still on Patreon. It's not really going to get you any additional content, though, although the Smash team will. Smashomash.com/Smash team. We also strive to keep this channel in existence. That's why we've got paid affiliate/sponsor links. One of those would be Hemp Lucid. You can find links below the video to the Hemp Lucid shop. So help the channel out that way if you like, if you're in the market, or if you haven't tried things like stress mushroom gummies and focus mushroom gummies, CBD body balm, CBD for your pets, and more. Again, link below the video as well as on the homepage. Another link you'll find is to the Amazon shop. I'm drinking Cameron's right now. Cameron's Scandinavian blend. Oh, so good. By the way, did you know that when we switched to organic coffee, we stopped getting the jitters from coffee? Yeah. So that's not any kind of a health claim. However, coffee doesn't make us jittery anymore. We only drink organic coffee. So pesticides, maybe? I don't know. Just putting it out there. So that might look expensive, $23.38. However, that is a 4-pound bag. So it's actually not very expensive at all. It is whole bean. So it's whole bean, medium roast. And I endorse this product, available at amazon.com/shop/smashomash for your drinking pleasure. We've also got our own subscription services site that we launched officially in October of 2021. Smashomash.com/Smash team. The best value is the gold annual paid-up subscription. And by the way, welcome to the Neo Renaissance. It's kind of like Patreon, just better because it's our own. And yeah, that's our subscription services site, smashomash.com/Smash team. Today's featured product is not the one I'm wearing. The one I'm wearing is MANSA, which stands for Make America Not Suck Again. Yeah, Make America Not Suck Again. Because the best way to get out of a hole is to stop digging. The other featured product is the Smash News Network, least busted name in news. So we do requests. This one was requested by a viewer. Did you pick up some merch yet with the logo as you requested? It's got the YouTube URL on it and our Smash News Network logo. Yeah, the least busted name in news. I know, facts. Watch out for all those facts, folks. They're very controversial, especially in the past 42 months. Oh, my God. Oh, check it out. David Hogg. David Hogg likes the Smash News Network. Check it out. There he is. David Hogg wearing our Tri-Blend t-shirt with the Smash News Network least busted name in news. I guess he likes facts. I don't know. Who knew? Who knew, folks? If you think it's a dig on CNN, it absolutely is. The most busted name in news, CNN. In contrast, the least busted name in news, SNN. And thanks for tuning in. Don't forget to press the like button, or we will find you and we will shame you. We're going to close out this thing with U.S. Doppler radar, clouds and fog, and water vapor. And we're going to focus on the lower 48. Here's this thing. There is Idalia. Here is clouds and fog. And you can already see additional cloud nucleation happening there in the Gulf. So there's a little dry air there, but not enough. It's going to become moist air rather promptly. And you can see it happening right here on the water vapor map. And here's your recap. U.S. Doppler radar. Clouds and fog, despite it being too dark to use the visible satellite. And there is water vapor. So hopefully that cleared things up. Hopefully you are able to forecast your own weather, whether it's in space or down to Earth. Once again, congratulations on realizing the channel exists. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.